What we'll do today is we'll start introducing object-oriented Python, because that's what we have included in your syllabus this time. And we will move from list of integers, list of strings to list of objects, okay? And then dictionary of objects and all. Just like C++ objects, but with the Python way of doing it. Okay? So let's start with a class in Python. Now, just before that, let's think back. What did we say when we said a class in C++? It's a class is a class is a class, whichever language you decide to use. So, every class we said, if you recollect, has a state and has a behavior. State is whatever is the data that you store in that class, that is called the state. And behavior is whatever the action, methods, functions which are there in that class, that is a behavior. We said for an employee, what is the state? Maybe the number of the employee, salary of the employee, age of the employee, name of the employee. These are the state. And what is its behavior? Behavior could be an employee can be hired, employee can be fired, employee can be given an increment, employee can be transferred, employee can maybe resign, maybe join. All these are different kinds of operations which you can do on an employee. If you encapsulate both of these together, we call it a class. So this is common whether we talk about classes in C++ or Java or C# or Python. Somewhere the way of creating will be a little different. And as long as we are able to appreciate the difference, whatever we learn in C++ can be transferred to Python and vice versa. So today what we are going to do is, we are going to create a class in Python called, let's say, student. For lack of a better example, we will say student. It could be anything, right? So let's see how do we create this. And remember we also talked about when we create a class, there is a thing of a constructor. And constructor was created in a special way. What was the special way that we had to use in C++? Same name as the name of the class, whatever it is. Should not return anything. And can have parameters or need not have parameters. Depends. Or can be both. There may be one constructor with parameters and one constructor without parameters. So depending on the way it is used, either of the constructors can be utilized. That story remains the same with Python also. Okay? So how do we create a class in Python? Okay, we will open an editor, practice 9. If you want to start typing with us, practice 9 question in Python. Are we there? If you come to the editor and say practice 9, you're there. Let's start. How do I create a class? Okay, class student. That's how you start. Class student. And just like in Python, you use a colon every time when you want to go to the next level of description. You go say colon. So you started a class. Okay. Then every method in Python, remember, it starts with a DEF. I think we saw that sometime earlier. So we will now have what is called a constructor method. Okay. And then I'll talk a little bit about constructor. So def, how do you label a constructor? There is a method called init. Now, there is an underscore before. These are special methods in Python. There is an underscore before the method name, and there is an underscore after the method. In Python, these are called double under or dunder. Dunder, D-U-N-D-E-R. That is called double under methods. Why they are called double under? Because there is an underscore sign in the beginning and there is an underscore sign at the end. These are, people call this dunder methods, people call them magic methods. So you decide to use what vocabulary you want, but these are the names prevalent in the business. So dunder or magic methods. methods. Okay, these are called magic methods. So all these special methods, and we'll see so many of them today, are called magic methods. Okay, so I think I prefer the word magic method, right? Somehow, though there is no magic involved. So all of them start like this, and all of them have one parameter. What is that? Self, which is the equivalent of? We just talked about this. What is this in C++ or Java is called self in Python. So whenever, of course, this is a pointer in C++, this is a reference in Java, and here self is also a reference. That is, you don't have to say this arrow in Java. In C++, because it's a pointer, you have to say this arrow. I hope you are understanding what I say. Because this is pointing to an object. Whenever we want to refer to any data member of that object, we can't use this dot. We have to use this arrow because it's a pointer. Here it's not like that. You have to use self dot. And in Java also you have to say this dot. So there it's a reference, here also it's a reference. Reference means the pointer is implicit. You don't have to say it. It's understood that it's a pointer. You don't have to express it. It's a pointer, no doubt. But it's an implicit pointer. In Java, in C++, it's an explicit pointer. So you have to say arrow. Okay. Right? Okay. So now this is the writing of the constructor. Now I'll write the constructor. So the constructor can be called with parameters also. Let's call it with parameters. Or you can initialize it to something. So we'll say A, B, A, age, and let's call it age, name, and roll number. Okay. So these are the things. Now just watch this line. Self dot age equals age. Self dot name, you can call it by another name also, doesn't matter, but I'm just showing it. Normally this is how it is done. Okay. If I was writing this in C++, I would have to first create these fields. Which three fields? Age, name and roll number. I would have to say at the top, int age, string name, and maybe depending on roll number whether it's a string or a number, either string or integer roll number. Would I have to say that or not? I have to declare the state explicitly in C++. Here, by writing the constructor in this way, automatically the state is getting created. So, in this case, the state has also three fields, name, roll number and age. But I don't have to declare them because C++, why do you have to declare them? Because its type has to be specified. String this, int this. In Java, in Python, the type is implicit. It's understood. It's dynamic and understood. So, when you say self.age and give a number there as a parameter, it's understood that it's going to be a number. If you give string as a parameter, that is in double quotes, it's understood that the name is going to be a string. So that's how it works. Okay? So now I have created a tiny student object. Okay? Now let's write a display method here. Def display, which will show this data in proper form. Okay? So you can write whatever. So display will print the data in whichever format you want it to show. So we will choose print, and we will say something like, we can use the format statement also, and let's use the format statement. Double quotes. You can either give it name parameters, that is, first is age, age is equal to flower bracket, name is equal to flower bracket. You can also say 0, 1, 2. Or you can give value for each place. Dot format. Okay, 1, 2. Dot format. What will we format it with? With age, name and roll number in the same order. So that ends there. And so this is how you do the display. I mean, this is one way of doing a display. We'll change it a bit later. Okay. So we have created a nice Python object. Do you agree it's an object of student? How many constructors does it have? One. You will realize soon that Python needs only one constructor. And we will tell you how when I compare it with the C++ constructor, but hold back. C++ you need more constructors. Okay? But Python you can make do with one. Okay. Now you can have more, but I'm just saying you can. One itself is very versatile. Okay. Now we are done with student class. Okay. Let's not add any more methods. Let's start writing our code. Now later we will also understand how to make it a module and all that, but let's hold back on that for a time being. Now I will create a few students and then let's do it. How do we create a student? Student S, and we give the data there. Spaces. Give age, name, string loop. S equal to? You don't say student, I am sorry. This is a S is equal to student. Student. The carryover from. Then we will say S dot display. So S is equal to student, because you don't have to declare the type. You just have to say S is equal to student with pass the parameter which the constructor requires. Init is the constructor. So like the constructor. So S dot display. Okay. So let's run it and see what we get, and then we will change it a bit. Display self. Every method needs a self. What did I do? Age is not defined. No. Okay. Yeah. I can't say because there is no explicit reference. Okay. So you have to say wherever you are using the fields. We forgot to do that. So we'll get this data. Okay, just the small mistake we made, we forgot to use, if I simply say age and all, it doesn't mean whose age. I have to use a self always. This object's age, this object's roll number, this object's name. That is what I want to do, display. Because being dynamically typed, unlike C++ where the state is outside and every method has access to the state, here the state is in self and self is passed as a parameter to everyone. So the state of an object is always returned in state, is always preserved in self. So I have to always say display self, I have to take that as the parameter. See, each method, which is a method of that class, must have the self. If you're just writing a general function, you don't need. But method which belongs to a class compulsorily must take self as a parameter. Then I say after the format string, in the format I forgot to say self.age, self.name and self.roll number. So you say that, it works as it is. So this is how you create a class of student. Okay. Now we will go and work on those magic methods of every class. Okay, and then we'll see some more interesting stuff. So is everyone with me so far? Are we able to make things work? No, yes. Whatever we have on the board, we should first of all be able to make it work on the screen. Yes? Should we proceed? Okay. Yeah. So I have S is equal to student 25 Gopal 101 and I have printed the data in S.display. Let's now add more magic methods and make our class better. Okay. Now, if I say simply, let me change line 10 a bit and then we'll see what to do. Okay. On line 10, I don't want to say, just because I want to display a particular object, I don't want to say S.display and write a display method. Like little intermediate. What I would like to say, when I want to show an integer, do I say I.display? If I say I equal to 5, and I want to show the value of I, do I say I.display or something? I just say print I, isn't it? No, yes. How do you work with your natural primitives? You just say print I. If you have a float, you just say print float. Or if you have a string, S is equal to XYZ, if you want the value of S, you just say print S. But if I try to do that on my object, which is S, if I say print S, it will give me a funny output. Just see what output it gives and then you will correct it. Okay. So just see, you put it on the next slide. Okay, please run it. Just say print S. You tell me what you get. Are you seeing some stuff there? You will see something like some name, some class name, and after that you will see a hexadecimal number. That is the address of the object. So, if you print an object, it simply gives you where in memory that address is, like a pointer, but don't use it. Don't use it like a pointer in C++. Okay, don't do that. But that number that you are getting, or that value that you are getting, that 0x something, okay, that is the address of the object. But we are not worried about it. And we don't want this to come. So, when you print an object, why can't I get a sensible output? So, now let's go back to our logic. Now when I print on line 10, I'm getting something. Okay? I don't want that something. What I want? Whatever display is doing, I want that to happen automatically without me saying S.display. I only want to say print S and I want a sensible, reasonable output of my object. That's not happening. When I say print S, it's doing what? It is doing something. Okay? Now, that something is coming from a default method which is inherited. That name of that method is again a magic method. Okay? So, what I am saying is, when I am calling print S, when I am calling print S over here, when I am calling print S over here, this print S, what's happening is, actually, the method which is called on S is underscore, it's again a magic method, called REPR. This method. This is called a representation method. How do you represent a Python object? This is the method which is used to represent a Python object. So, this method automatically is getting called when I print object. I am not calling it. But this method is automatically called. Now you will ask, where is this method coming from? I will answer, this method is by default there in every Python class. It comes from its object class, which is its ancestor. We will not talk about inheritance too much today. But imagine that always every Python class has a method underscore REPR, that's the name of the method, underscore method. So that method, which is a magic method as we know, that method is automatically called. And the default method is printing what you are seeing on the screen right now, which is the name of the class and some address. We don't want that. So what we'll do, we will supply our own definition of this method. By doing that, because we know this method is getting called, and this method by default is writing that object name, class name and some address. We don't want it. Now this later we'll learn in computer science, in your C++, as overriding. We will override the original REPR magic method with our own version of REPR method. By doing that, we are supplying a new REPR method because we know that print calls that method. Print depends on that method. So by supplying the body for that method, we will give our own version. So what we can do is, instead of calling it display self, we'll just change the name. We'll say REPR. There is one underscore or two underscore? Yeah. So there are, it's the double under, remember? Before and after. Two underscores before, two underscores later. I think that you have figured out by now. Okay, so I am writing that REPR self, and what it will do? The body won't change. Now automatically this method will be called on line 9. I don't have to say line 9. No. I don't have to say print, or I don't have to say s.display to call that display of object. So this is a more elegant way of writing than supplying a display method. You should actually have a method which is called representation method. So that is what we gave. So line 6, we have created a special method. Special because it's a magic method, remember? These underscores have their own names. These methods have their own names. So REPR self, and now if what we are saying is going to work, we are going to see the same object coming again. So let's write this, run it again and see what we get. We should see the similar output like what we saw when we wrote s.display. Now we have not written str also. Okay, so that is another method. So I think rather than REPR calls str, no? Str calls REPR. Okay, we have to return that. So okay. No, we can't print it, we have to return. Yes. Small change. Okay. Now let's see what we can also call str, but this is better. Let's not worry about str for the moment. We made a small mistake. See, when you write it as a method, it has to return that object, not print that object. Object means the formatted string. Display you can directly print because it's called display. These magic methods don't work that way. Magic methods have to give back something. So whatever the protocol is there, the magic methods must stick to that protocol. REPR protocol is what? That it should give what should be displayed on the screen. So you have to say return whatever is displayed, and it will be called, when you say print s, automatically that REPR method will be called and it will cause that display to happen. Okay? So how many magic methods have we seen so far? 2. One is called the constructor method, the other is called the display method. Now some people don't change underscore REPR, they change str. But I think this is enough because str internally calls REPR. So it doesn't matter. If you change this, anyway the change will be there. There is some small difference between display and representation, but right now it doesn't matter. Okay. So we have these 2 magic methods. Init, both of them take self as a parameter. Okay. The init because it needs other data, it is taking other data also, and using it to initialize the object. Okay. So we have created a student object and we have learned how to display it. Now there are many such methods. Okay, so now let's create yet another method Okay, what we will do is, we will say, we will create one more student object. Let's call that S1. Let's call it S1, S2. S2 with exactly same data. Now we'll say, we'll ask for a Boolean return whether S1 is equal to, okay, we'll just write the code if S1 equal S2, we'll say the two students are equal, print, students are equal, some line. Else we'll say students are not equal. Straightforward logic. Yes, no. I created two students with exactly same data. Are you with me? I created two students with exactly same data and I am comparing them with a equal sign, and let's see what the Python has to say. Python interpreter has to say. Okay. Yeah. Now they will say students are not equal because by default they are comparing the IDs of the object. ID means, ID is identity of the object. How many IDs are there? Though the student data is same, their individual ID, you can ask for the ID of the student also. Okay, I'll print that in a moment. ID of the student means what ID Python has given to that. That will be compared by default. That means when you say equal, it is comparing the ID. If you want, we can print the ID of both the students. You will see it's different. Print ID of ID actually. ID of S1 and then print ID of S2. They are two different IDs. Though their data is same, IDs will be different because IDs are an ID of the object. Because they are two different objects. They are not same object. The data is same. Okay. So if you compare it, the values you will get may be something else, but I think you will make out that their IDs are different. Yes? No? You are following me or no? So by default equal compares the IDs, and because the IDs are different, they are different. Okay. What do we want to happen? What is our desired output? It should say true. What should say true? The two students are equal, it should say no. Because I am not bothered whether IDs are same or IDs are different. To me, if the name of the student, age of the student, roll number of the student is same, the students are equal. I should, for my logic, we can't depend on IDs. We have to depend on some other definition of equality. And our definition of equality is not anything to do with IDs, which it is by default, but we want to change it. Just like we change the representation for how an object should look like. Right? So, how do we change the interpretation? Okay. So, we will say, now, let's write the logic. So, we'll write the equality logic. So, def EQ. This is the equality logic. How does one object equate with another object? Self and other. Now remember, equality will need two parameters. Why will it need two parameters? Self is obvious. Every method needs self. And other. With whom are you comparing? No, yes. Just like in the morning, our plus method needed one extra parameter. Remember, plus had one parameter, other linked list. There this was not needed. This is implicit there. In Python, the equivalent of this, which is self, has to be explicitly said. That is why we are having two parameters. Self means current object. There the current object we didn't have to say anything. This automatically used to point to the current object. Python doesn't work that way. Python there is a self, it can be called anything else also. But that has to be passed as a parameter, the first parameter. Okay, so now, how should we say anything? When do we say things are equal? So we'll say if self dot age, we'll write the logic for that. Equal, other dot age, return and all three, and self dot, here and is and, more user friendly. Self dot roll number, or self dot name is equal to other dot, and self dot the third field roll number equal. This is on basic data. Return true. No? True is the uppercase. Else return false. Yeah. So we have written the equality operator or equality method or function, which is a magic function in the class. So we have now three magic functions in it: REPR for display purposes, and another one for equality purposes. You with me? Okay. So. Now, let's say, let's run it. Okay, there was small error. We didn't write equal and not times. Okay, so now, if you see, because now our equality definition got called. Did you understand what happened? And as per our logic, two students are equal when their data is equal. Data means name, roll number, age, all of that are equal. Then the two students are deemed equal. So you see what happened. Go back. See, we said, look at line 8. That is the equality operator, which is invoked on line, on line 17 when you say S1 equal S2. If S1 equal S2, then we said, what will happen? If we didn't write equality, it was comparing automatically ID, which we don't want. We wanted to compare the actual data S1 and S2. If you want that to happen, then our student class must have a magic method whose name is EQ. That is a equality check. And it should take two parameters, the current object on which comparison is being done and the other object. That is, in our statement when we said, if S1 equal S2, self will be S1, other will be S2. So that is how it will call the equality operator with two parameters, self and other. So that is how the values will be set. And invocation will happen accordingly. So what are we doing then? If self dot age is equal to other. If you want some other definition of equality, Okay, now we will come to that. Now, not of equality. Equality, let's keep this definition. Now, can you say if one student is greater than another student? When will you say one student is greater than another student? If he is older. If the person is older, we'll say he is greater. Otherwise, we'll say he is not greater. Are we clear? So we have to provide a logic for greater. Now, if you don't provide the logic, what will happen? Okay, let's go to the line. Let's write one more line. If S1 greater than S2, okay, print S1 is bigger, S1 is older. Okay. And else print S2 is older. Some logic. Now, if I try to run it like this only, now if you get what I am saying, you will understand. How does Python know how to compare two students? How will Python know that? How do I say one student is more than the other student? Can you say? How does Python know that age should be taken into consideration, not name, not roll number? No, Python doesn't know. You agree with me? So let's see what Python does in that case. Let's run it. Okay, it says greater than is not supported between instances. Instances means objects of class student. Are you understanding? That's what it's trying to tell you. Which cannot be compared. How can you compare two students? But your condition is, but I want to compare two students. I want my line number, can I go to the code? I want my line number 21 to work. Are you with me? Right now my 21 is not working. It's saying I don't know how to compare two students. I don't know. I don't have the logic. I don't have the mechanism to compare two students. You tell me how. So I can tell how. That age is the reason you can compare, or age is the way you can compare. So for that, I have to write my own logic. Anybody knows? Def? No. What should I call the method, the magic method?
Without it also?
GT, greater than. Equal is equal. GT is greater than, and I am sure you will understand. There are methods for less than. What will the method for less than? LT. There are methods for less than or equal to. What do you think it is called? LE. What is greater than or equal to? The same token, G. So you can write all these magic methods and Python will learn how to compare two student objects. Okay. So return, we have to return a true value or a false value always. For greater than, less than and all, we have to return true values, true or false values. That is, we have to return Boolean values. Now, look at the line 13. Again a magic method, greater than. Yes? That's how you write the magic method greater than. It will automatically get invoked when you say greater than. So, now, let's see. We have does everybody understand what we have written on line 13 and 14? We have given a definition of greater than. Definition of greater than is age of one person should be greater than the age of the second person. Then first person is greater than the second person. This is our definition. You can give any definition that you want. This is your logic, your class. If you wanted to follow some other logic, it's up to you. Okay, so this is greater than, and it should return a true or false. So in this case, obviously is not greater than, so let's say, now it will work, but the greater than logic won't work because it's not greater. 25 is not greater than 25, right? So it will give a false. Let's see. Yeah. It's saying S2 is older. Now you know why it is saying that, right? Our logic is what? If S1 greater than S2, yes, no. We are saying S1 is older. Any other condition, S2 is older. It's going to that. You can change it a bit. What you should say? If it is greater than or equal to, or greater than but not equal to, then you should say. Okay, you decide what logic for greater than should be. Okay, I am not going there. But I think, are you understanding how do you write greater than? So, similarly there are other magic methods, less than, LE, less than or equal to, greater than or equal to. There is another method called not equal to, any. Now you will say, is it not understood? Well, but they do have a method called not equal to, if you want to override. Generally when things are not equal, they are equal returns false, they are not equal. But if you want any not equal to operator to be used, you can use that. Okay. Okay. This is interesting, we'll go there sometime. Not equal. Okay, but not right now, let's not go. Okay, now we'll come to another set of interesting operators. Okay. Now, I will change my class a bit to have one more field, okay, called marks. I have name, age, roll number, and let's have one more field, marks. But marks is going to be a list because marks are not one. Okay, so let's go and change our thing to create an empty list. You with me? We added one more field to our student, which is marks. Are you there or not there? There? Okay, that I want it to be used as an array on student. Okay, so I'll tell you what I mean. Okay, now, okay, it's empty, so it's initialized to empty, doesn't matter. Okay, so let's go down. Okay, now you'll have to think a little with me, little smartly. Now, I want to say, there are, for a student, let's say, there are 3 subjects. 0, 1, 2. Okay. 0 is the first subject, 1 is the second subject, 2 is the second. So, I want to be able to say, okay, let me just write, come down. Further down. We'll add here, 30. 30. So I will say S1, 0. S1, like a list. I want S1 to be used as a list. When I use it like a list, it means that I am giving the marks. So S1, 0 is equal to 30. First subject marks. 30. S1, 1. Do you understand what I am doing? I am using sometimes S1 as an object. This time I am using S1 as a list. Are you at least understanding that I am trying to use it as a list? We'll call it some other name and give it. Interpretation is for us to give. What should be treated as its list? Okay, now we are clear that marks will be treated as its list. Okay, now, okay, this you'll have to think a little and understand. See, first look at these lines. 30, 31, 32. Look at these lines. Do you find something peculiar about this line? There is something peculiar because S1 is not really a list. What kind of animal is S1? It's a student. It's an object or instance, as we call it, of class student. S1 is an object of class student. It's not really a list. But do you see what I am doing? I am trying to use it as a list. Now, first of all, it will reject this. It will not allow me to be used as a list. Okay. So, okay, let's see what happens on our code. Then we'll change it. Now you see. Acha, you wrote self.marks. Acha, okay, sorry. We have forgot to add something to the marks. Okay, sorry. We have to give an empty list here and an empty list here. We have to supply this parameter now. Yeah, because we have set self.marks, we forgot to update it here. Okay, now it will work. That part will work, but still there will be issues. Let's run it and see. I hope you are doing as we go. So now the earlier part is okay. Now it's saying, I don't know how to do this. I don't know how to do what? I don't know how to say, when you are saying S1, we know S1 is not a list, it's an object of class student, and you are using it as a list by putting square bracket, 0, equal to this, that, all that. Okay? Now, it's not working, correct? It's not working. You are seeing. Now I want to make it work. I want to use my student as a list with a particular meaning that when I use it as a list, all the values that I supply are going to become marks. Again I am repeating. I want to use student as a list only for giving marks, give the values for marks. So when I use it as a list, it's my understanding that when you say S1 of 0 is giving the marks for the first subject. S1 of 1, I am giving the marks for the second subject. It's understood. Okay? And I know that is very intuitive. But how does it work? How should I make it work? Okay. So for that, again, what should I use? Some magic method. Now, you research and tell me, what magic method should I use? So that line 30, 31, 32 work. What magic method must I add to Python in order for this to work? Think and tell me. Go to the net, do a bit of research and tell me. What is the name of the method? Index, yes. What is the name of the method? I have to add one magic method to my class, Python class. I have to add a magic method. What is the name of that magic method? Huh? Who is that? Get or set? Yeah. What are the parameters? Self will always be a parameter. Then name. Okay. Let's say there is no mark. I mean the field is understood. Index and value. Okay, you're right. Self. Value. So you have to give at least 3. No, yes. You have to give self. Self is always there because you have to refer to the Python object. Index. You have to give the index because where 0, 1, 2, that is the index. Because even though you will be maintaining a list, in which position in that list you have to add. Then value which you have supplied. So when S1 on line 30, what will be the parameters? Set item will be called. Self will be of course pointing to S1. Index will be 0. Yes, no. And value will be 30. These 3 parameters will be passed. Am I right or wrong? Automatically. I will not pass. It's Python's interpreter only which will pass these three values. So now I will say, okay, go up. So I will supply this method now. Def set item I small no set item parameters first self key value. Key is the index, no? So okay, now tell me what will I write here? I want marks to be set. Marks, first mark, second mark, depending on key. Key is the index. You can call it whatever you want. You want to call it index, you can call it index. Name doesn't matter. So what should my body be? Yeah? Self dot marks. Marks of?
Equal to value.
Marks of key.
Equal to value.
Equal to value. Correct? Self dot marks, okay, self dot marks, this interpretation. Go to self dot marks, then use the key as the index, that is what it is, and whatever the value is there, put the value there. So now, will this work? Now will that line give an error? Okay, let's check. Earlier it was giving an error when I said line 31 or whatever. Okay, let's run it. I still have an error. It went there. List. Oh, key and value is gone. This doesn't come. Maybe you can also check why it's not working. It should work. Okay. The version is correct, no? I forgot to give memory. Okay, but just one. See, so far, what was happening is the set item is okay, nothing wrong. Problem was there was no space, that's why it was saying index out of range. If you run it earlier, it was saying index out of range. It so happens that if you are going to create objects like this with marks, the size has to be pre-allocated. Okay. Now, we have to give some size, whatever the size may be. So how do we give size? That none. None is null. What is null in C++ is none in Python. So we are saying self.marks, that star means replicate. Replicate size number of times. Replicate what? None several times. Size is size of the array because I am going to store 3 marks. My marks is equal to an list of how many elements? 3 elements. Value of each element is none. Okay. You would like it as none, or you can even make it 0. Okay. Because we are storing it in integers. Generally, if you have strings there, you make it none. Otherwise, you can make it 0. So instead of none, you make it 0. But we have to allocate some size. What does this mean? By default, everybody's marks are 0. And how many marks are there? 3 marks are there. This is what we are saying. So, because we had not allocated this memory, when we tried to do 0, it was saying index out of range. That is, it is not saying that there is such index available. Now, it will have 0, 1, 2 as the indices available. And all values will be 0. Because what is self.marks? 0 star size. When you use it like this, don't think it is multiplication. It is replication. I think you understand the meaning of the word replication. So you put a square bracket, star something, it replicates it that many number of times. So there are marks which are replicated, that is 0 replicated 3 times. So it's a list of 3 elements and each element is 0. That is what we are saying. If If you want it to initialize to something else, that is also fine. So we have initialized marks and all marks are 0 at the moment. Now, I have initialized the marks, but I am not doing anything with the marks, so I am setting it. Now, what you can do is, when you print an object, you can print the average of those marks. So, okay, let me do it like that. When I say display that object, display, you don't know which REPR. Okay, there we will say age, name, roll number, and let's add one more field now that we have, marks equal to 3. Okay, but marks, what we are going to do is format, name, roll number, comma. Now we are going to add 0. Okay, let's put the sum instead of average. Okay. Okay, you want to just do a sum. Okay, do a sum. Like that we can do an average also. Let's sum. Go back to sum self dot marks. Sum of. Sum is a built-in, no? So, yeah. So let's come back. So we have changed the display to include marks, sum of marks. Come down. Come down. Achha, if we display S1, we are displaying S1. No? This say print S1. Okay, print here. Print S1. Okay. Let's see what we get. Then we'll think about it. So when we print S1, we are getting marks is equal to 135. You know why I got 135? All of you with me? Why did I get 135? Go back. Come down. Yeah. See, I have said marks of the first subject is 30, marks of the second subject is 45, so 75 plus 60, 135. I don't know how many of you are following. So the marks, when I said print S1, I changed the REPR to include sum of the marks array. Okay? Self.marks. Sum self.marks gives me the sum of self.marks. Because self.marks is a list. And how do you take a sum of a list? You just say sum and you will get the list of all the, sum of all the elements in the list. So, if you see what I am doing, I am saying S1 0, I am using it as a list. When S1 0 is called, what is called? Set item is called. Magic method. So, that magic method, set item is called with 3 parameters. Self, the current object that is self S1. Second parameter, 0, which index I have to fill. And which value I should supply. So, the value I should supply is 30. So, it will get fixed as the first element of that marks array will be 30. Similarly, the second element will be 45. Third element will be 60. So I will get marks. And now I can use my own logic for comparison. Earlier I was comparing by age. Now I can change the comparison. When do I say one student is more than another student? By comparing the sum of marks of the first student to the sum of marks of the second student. Are you with me? Okay. Now, let's create 3 students with similar data. And then I'll show you something else. So, let's, no. You have to create S2 first. S2 is there? S3. Student. First is age, then is name, then is I think roll number. And how many marks? 3. Everybody has 3 sets of marks. And now we'll say S2 of 1 is 3 of 1. Change the marks. Give lesser marks to S3 so that we will see little variation. So S3, 0. Okay. Now, I'm going to ask a slightly varied question. I want to sort. Okay, first let me add all these S1, S2, S3 to a list. Create a list. Let's call it S list. S list is equal to empty. Empty list as of now. Okay? I want it to be a list of students. So I will say S list dot append S1, slist dot append S2, and slist dot append S3. I hope you have understood that set item. That's the only little bit tricky thing, but once you figure it out, you have to give space. You have to try a bit, it will come. So, now, if I print slist, okay, let's print slist. Now, what will I get? What will happen? What is slist? What happens when you print a list of integers? It goes to that list, goes element by element, and displays that element. Yes, no. That is what it does. So by a similar token, by a similar understanding, what it should do now? It should go to each element of slist. What is each element of slist? Each is a student. No, yes. Each element of slist is a student. All of you agree? So it will go to each student and print each student. We already have given a method to print student. Yes? So I should see a list of students, their name, roll number, age, and their marks. Not marks, sum of the marks. Remember? In our REPR method, in the formatted string, we are displaying the sum of the marks. Okay, so let's see what we get when we run it. Now you see the list has been printed for each student, name, see it's going to each one and printing. So for the first student, name is 25, age is 25, name is Gopal, roll number is 101, marks are 135. Then second student, age is whatever. So on each of the student, it has used our REPR method, because that is what is the printing method. Printing each element of the list means it has to use that REPR method, representation method. REPR stands for representation. Representation method, and it has called it. Are all of you with me so far? No, yes. Now, I want to sort this list on marks. Are you with me? I want to sort this field on marks, or rather I should say sum of marks. Can I write the sort? Look at the way I am writing sort. Okay? So slist dot sort. Now, if I just sort it, what will it say? It will say, how do you want me to compare these people? You have given me greater than or all that, but you have not given me less than and all that. So I don't know how to compare. So I'll use some ad hoc comparison. Let's see what it gives. Always try. Okay, slist dot sort. I have not supplied any parameter to sort it. I can supply a key function, but I will do that in a moment. So I am sorting. Okay. Now, when it's sorted, I guess, I think it may have sorted on the first field, but I don't even know how it has sorted. Maybe sorted on ID or sorted on age, or can we try a different age? Age is in ascending order. So just make leave it like that. Let's see what happens. It actually can use some funny sorting method. Yeah, that's what it is doing. Can you see this? Last line. No, yes. What do you think it has sorted on? First field. Why age? Nothing specific about age. It's not that it likes age. It happens to be the first field in that object. Age happens to be the first field, so it randomly picked up age and decided to use it for sorting. Nothing wrong with that. But we want it to be sorted the way we want it, not on anything. Correct? So let's see if we can supply our own sorting logic. Okay? So let's be a little clever and let's say one more line. SES dot sort, but this time we are going to supply a key function using what is called, what should we use? Lambda. Now, I will write a sort. So key is equal to lambda of x. X is what? Each object. Each object, you have to say on what field should I sort. Okay, you have to give the field back. Lambda x. What should we return? Lambda x. X is what? Each student. I want to sort on sum of marks. X dot or sum of self dot. But I want it to be sorted such that the guy with the lowest mark comes first. Ascending order of marks. Ascending order. Lowest mark, lowest sum of marks. Every student has name, roll number, age and marks. So I want it to come in a way such that the lowest mark will come first. X of marks, x dot marks. So we are saying choose this field. What is the field? Sum of x dot marks. Choose that. What is x? Each student represents x. So this function, lambda function, will be called on every student with x, whatever you give the name there, x, representing each element. Each element is what? Student. Student has marks? Yes. Those marks can be summed? Yes. That field, that sum of marks, should be used as a criteria for sorting the student. It will always be by default ascending sort. So let's try how it works. Okay, now if you notice, it is sorted in descending order. No, it is not sorted. Print. Oh, after that I didn't print it. Print this list. Now it's correct. Sorry, I did not print. I did not display the list after I sorted. Are we clear now? So, it is automatically ascending sort. Ascending on what? Sum of marks. Yes, no? Did we read so far? Are you able to follow? This is how you will learn, not by just wondering. Okay, so you see the data. The marks are 109 is first lowest, then there is something else, something. 105 came before, later. No, it's not. Huh? Sorry. First one is, sum is not printed. Okay. So first one is 70, sum of marks is 70, second one is 105. No, it's correct. Okay. That field is called marks. Okay. So that is how it is printed. We are printing sum of marks, but we are calling it marks. I think we should change it. While printing, we should say S marks or something. Okay. Anyway, it doesn't matter as long as we are clear. Now, what if I wanted this sort not in ascending? By default, it's coming ascending. 70, whatever, 105, 155. Those are the marks. What we have. What if I want descending? Highest mark first. What should I do? Comma. I should say reverse equal to true. One more parameter I can pass to sort. By default, sort is ascending. So you can change the sort. Reverse equal to true. Reverse equal to true means whatever is the default way of presenting, which is ascending order, reverse it. So you get in descending order. Let's see whether it comes and print after that. Good. Okay, now you can see it came in the descending order. 155 came first, then something else, 105 I think, and then 70, whatever, depending on the screen you use. So this is how you get reverse order list. Is it making sense? So we have learned how to create a class. We have learned how to write some standard magic methods, also called double underscore or blender methods. We have also seen how do you implement all these most of these magic methods. This is the basic list. REPR, init, equal. Under equal, there are many. Less than, greater than, less than or equal to, greater than or equal to. Because remember, in any language there are symbols. Greater than, all this. So, now are you getting an understanding between these set of magic methods and operator overloading? What we discussed in the morning regarding operator overloading and what we are saying now about less than, greater than, less than, equal to, whatever, equal to. Do you understand some parallel between this? No. Are you getting some sense that there is something here in these magic methods which is similar to whatever we discussed in the morning called operator overloading? There we added plus. Here we can't add plus. Or is there a way? We'll think about it. But something very similar or comes through these magic methods. Not same, similar. Okay? So you have to think like this. You have to think magic methods, you have to think operator overloading, and don't get mixed up. You will get mixed up if you don't practice. As simple as that. And then we also added one more method, which we call the array method, like treating it as a list. Remember we added that set item method? That was another method. Now, in C++ you can do exactly that with a with a student object that when you add, there it is called subscript method, and the operator will be square bracket. Okay, maybe tomorrow or sometime we will see how to do similar thing in C++. Similar as what? Ability to put a square bracket, that is S1, 0 we did, and whatever value we gave went and sat automatically in marks. Now how do you do that in C++? Okay. And understand how it works. So there is some thinking to happen there. Okay. For today I think we are kind of done. Huh? One fine. So today we are done.